simulation because it has its own language and everything associated with it.
Yeah, so one of the big challenges with advanced materials is um, that now we have the freedom to combine different materials in different ways. And the challenge is how do you predict those properties from those materials? You don't want to go to the lab and, and experimentally test every type and every possible combination of materials. So what we're doing is we develop a platform that is enabling engineers and material scientists to do that virtually. Um, and now material developers have the freedom to account for all those different types of combinations, different types of materials, how they interact. They're able to understand very well how their material behave, and now think about innovative, innovative ideas where they can now come up with new materials or new ways to combine existing materials to achieve some specific performance requirements.
Now, are they things like the increased hardware power, graphics, high performance computing, and whatnot? Is that really helping drive the needle along in
Yes.
some ways?
Yes, it's a very good question. It's one of the big challenges we have been facing over the years as we develop the solution. So our approach was we first made sure that we have an accurate methodology. And the methodology would require you to have a different individual material microstructure models for each integration point in your final element model. And we have a very strong coupling between the two models. So you have an airplane wing where you're using um, either one of our partner solutions to model the airplane wing or our own standalone solution. And on the microstructure level, we are solving using multi-mag the microstructure model. It's it's really bringing the finite element approach to the microstructure level. Now you can imagine if you have 100,000 integration points, you have 100,000 new microstructure model. That's big simulation. So what we've done to overcome that, in addition to high performance computing, was we developed new mathematical formulation, a new data compression algorithm that combined together they give us up to 1,000x gain. In average, it's between 100 times and 400 times. So we're really bringing simulation that used to take 24 hours and 55 gigabyte memory to run in a laptop computer.
Right.
Now only takes 12 minutes and 2 gigabyte memory.
Right.
And with the same level of accuracy, which is one of the biggest drivers in our company.
You always want it accurate.